Welcome back. We're about ready to begin our second video from Unit 1, continuing our look at problem solving. So let me go ahead and share my PowerPoint with us. And Liferly should be happy and joyful. All right, here we go. All right, at the end of our last problem, we saw some interesting techniques that might help us. So let's go ahead. And here comes problem number 3. And it looks like we've got a new attack, some kind of a table or some kind of a sketch that we might find useful. All right, so go ahead and read the problem. We got Jesse and Ava. They're starting a new job, same day. All right, Jesse shows up to home office every 12 days. Ava shows up every 30 days. And the question asks us, on what particular day will they both be in attendance at the home office? And again, you could certainly approach this problem a lot of ways. A great number of young students. And again, I realize the 30s may be a clunky number. Maybe I would have been better served with a smaller number there for the young learners. But for us, I think we'll be okay. So what we could do is we could generate a list of multiples. Jesse's there on day 12, on day 24, on day 36, and so on. And we would do the similar kind of thing for Ava and try to find a number that occurs in both of those lists. So the problem says, well, why don't we make some kind of a table or a sketch? And I say, hey, why don't we? So here's a lovely table created by dear old Dell. Problem in front of us in the lovely peach text box. And Jessie, she's in there every 12 days. So she's in on day 12. She'd be in again on day 24. Looked like we sneaked Ava in there on day 31st. And here comes Jesse again on 24. And again, if 24 would have appeared in both of those chains of numbers, we'd be finished. But it looks like Ava's not going to be there on day 24. So the first day she's there is on day 30. So what I chose to do on this chart was just go ahead and run one more in for Ava. So she shows up again on day 60. Let's run some more days for Jessie. You guessed it, she'd be there on day 36. She'd be there again on day 48. And the next time Jesse's going to pop on in, you guessed it, day 60. And we have now effectively solved our problem because we found a day number that occurs in both of those lists. And you guessed it, my friends, on day 60, both Ava and Jesse will attend the office. So by process of using some kind of a sketch or some kind of a chart, maybe to organize our thoughts, we can go ahead and solve it that way. All right, problem 4, diagrams. I have to be honest with you, I am probably the world's worst artist. So we're going to go ahead and approach a race here. We've got Izzy and Jake, and they're running a 100-meter race. And we got 3 particular sets. All right, it's important to note that for this problem and for all parts of this problem, the speed of the runners doesn't vary. So no one gets faster as the races and no one gets tired and slows down. On the first race, Izzy was at the 90-meter mark when Jake crossed the finish line. So yeah, on the first race, Izzy didn't quite get there. Jake went ahead and zoomed on by, and you guessed it, on race number 1, Jake would have been the winner. Okay, so this is basically a little picture. Here we go. You ready? So at the finish line, we got Jake zooming across, and there's Sue just didn't quite get there. Okay, so the winner of race number 1 obviously was Jake. All right, so Jake lining up to go again. Speed doesn't vary this time though, because Jake gets tired of winning all the time. He says, Sue, why don't you start 10 meters before the start line? So Sue's going to line up right there 10 meters before the start line, and Jake lines up on the start line, and they go. And I remember what we learned on the first race is in the amount of time it takes Sue to run 90 meters, Jake can run 100 meters. So, okay, bang, guns up, off we go, and you guessed it. In this particular race, they are going to cross the finish line at the exact same amount of time. All right, so it's a tie. All right, so remember, Sue runs 90 meters in the length of time that Jake can run 100 meters. And on race number 2, you guessed it, they tie. All right, so here comes another set. Now watch this. This is an entertaining little action. This time, what's going to happen is Sue's going to start at the start line, and Jake's going to begin 10 meters behind the start line. Now, on first hunch, you might think that this is going to be the same result because it looks like there's that same 10-meter offset between where the people are lining up. This time, unlike last time, this time Jake is lining up 10 meters behind the beginning start line, and guns up, bang, off they go. Okay, let me put my people up there. There's Sue, she's getting ready to go, and there's Jake lined up 10 meters back, guns up, boom, there they go. And now there's the finish line down the stretch. And oh, baby, look at that, will you? At the 90-meter mark, they are exactly tied. Okay, so what's happened is Sue has run her 90 meters and Jake has run his 100 meters, and they are dead even at 90 meters out with 10 meters to go to get to the finish line. And now you're sitting there saying, well, geez, how am I going to know who wins? Well, remember back to the very first race. Who's faster? Yeah, Jake. So if they ever start at the same position, in this case they're starting at the same spot, 90 minutes or 90 meters down the racetrack from the start line. You guessed it, in that 10 meters that remain to get to the finish line, Jake is going to be faster. So you guessed it, Jake will win the race. So again, diagram can be helpful if you've got good art skills. This is a really cool way for kids who have artistic talent to get a bridge over to a subject that maybe hasn't been as successful for them. Let them draw it out. Bust out the colored pencils and crayons and go crazy. All right, let's look a little bit of a guess and check. You can remember when you were maybe ninth grade or so, and you said, well, I think the answer is this. And teacher says, well, how did you get it? And they were expecting you to solve something algebraically. And you did the old guess and check approach, and your algebra teacher is probably a little disconcerted. He says, I know that's kind of JV. So for the youngsters, though, in the primary grades 1 to 3, the notion of guess and check is a valid approach for those guys to solve math problems. And they don't tend to be very deterred if the first or second or sometimes third or fourth answer doesn't work. They keep plugging along. And we want to encourage that at young ages. But as they get older, we probably want to sneak some algebra in there and maybe look at a bit more algebraic solutions for our problems. All right, your first assignment from Unit 1 is a selection of problems, much like the ones that you've encountered on the slide so far. All right, so I'm going to say, I want you to go into the Moodle unit, pull down assignment 1A. I think it's about 8 or 10 problems, maybe a fewer than that, and go ahead and solve them and then send me solutions by PDF. And that'll be your first assignment from Unit 1. All right, it's a selection of, I think it's about 8 problems that I'm going to ask you to go ahead and attempt to solve. Use the models that you've seen so far and see if you can apply them to solving the problems for assignment 1A. I'm going to let you go ahead, but I'm going to continue the PowerPoint here, and we're going to move through. And oh my gosh, well, yeah, look at that. We walked right into the setup for assignment 1B. So this is your first selection of problems from your textbook. And what you'll see on this slide is where they are page-wise and which problems you're being asked to solve. So you'll see that in this text, we have section 1.1a and we have also 1.1b. And then later on, you'll even find there's a math connection section. So I've selected some problems for each of those. Solve them on notebook paper, solve them on a loose leaf, whatever, and then send me your solutions as PDFs, and you will have successfully completed the first 2 assignments, 1A and 1B from Unit 1. So again, we're going to move along on the PowerPoint. Oh, will ya? Look at that. We are into section 1.2, where it's time to explore some patterns. There's your overview. What are we going to do? We're going to look at inductive and deductive. A lot of time in this section spent on sequences, arithmetic and geometric. All right, so that I like this slide a lot. Math is a study of patterns. What can we draw from a look at things and try to figure out what we might be able to throw in terms of knowledge based on what we've seen? I like this problem. It's not intended to be difficult. The problem is if you can look at what's there and form some kind of an analysis, how are those first 3 numbers related, and what might you then predict would be the next 2 numbers in that sequence of numbers. So it looks like if you process this, I think the way I kind of intended, you would realize it looks like the numbers are getting smaller each time, maybe by a fixed number. It looks like that number's 5. So you might predict the next number would be 10. And the next number would be 5. And what we've done is we've come up with a conjecture based on a pattern that we've already looked at. And that, my friends, is inductive reasoning. Second one's a little tougher. To get from 12 to 14, we increased by 2. From 14 to 17, check it, we went up by 3. So it looks like the increase this time is not staying steady. It's not staying constant. It looks like it's getting 1 bigger each time. So if we add 3 to 17, all right, once we added 2, and then we added 3, and then, we're going to add 4 to 17. You guessed 21. And it looks like that if we add 5, we'll get to 26. If we add 6, we'll get to 32. Looks like the next guy should be a +7, and you guessed it at 39. So this is a good process for us to use with kids. Just make sure you clearly show enough of a trend so there's no chance for confusion in terms of what you would have for the numbers that are being placed in the blanks. And that, my friends, ends video 2 for unit number 1. I'll be back shortly with video 3. You've got some assignments you can crank up. Come visit us shortly and we'll get video 3 fired up. See you then.